Welcome. We're looking at Module 3, Task 6, looking more about polynomial functions and the definitions of polynomial functions and some analysis with that. So here's your formal definition, A representing the coefficients, and you can see in descending order x to the n, x to the n minus 1, until you get down to x to the first, until you get down to x to the 0th power. And then you've got your a to the n and a to the n minus 1, just showing that it's a different coefficient until finally you have a to the 0, which is the coefficient of x to the 0. The a coefficients are real. N is a non-negative integer, because we've said polynomials can't have denominators with the variables. So it's one or more monomials. It could just be one of these with real coefficients. A is real, and non-negative exponents. So n is not negative. All right. So they ask you a couple questions like h and I. Well, h is, yes, this is a polynomial, because a equals a half, and you have x to the first as the term. But g of x is not a polynomial, because you have a denominator with x value. Similarly, yes, x squared, the parent function, is polynomial, but x to the half is not. No fraction exponents. That's what disqualifies it. And then there's this discussion of close. Close means when you do an operation, it's still part of the same set. So for example, when you add two even numbers, 2 plus 4, if you're looking at the set of even numbers, you get 6. We would say that it's closed because the sum is also an even number. But you can look at some other examples. What about odd? Is odd closed under multiplication? Sure. 3 times 5 is 15. Odd, odd, odd. So we could say, yeah, it's closed. Okay. So there's some other ones here that you're looking at. So the one is the sum of a quadratic linear is a cubic. This is false. X squared plus x is still a quadratic. The sum of a linear function and an exponential is a polynomial. Well, 2 to the x plus x is still not a polynomial because of the exponent here. So we're going to say false. The set of whole numbers is closed under subtraction. No. 2 minus 3 equals -1, and -1 is not a whole number. Cubic function subtracted from a cubic function is a cubic function. False. X cubed minus x cubed minus 1 is equal to 1. That's not a cubic function. Some other good ones here. The set of integers is closed under division. No. 2/3. 2 divided by 3 is 2/3 is not an integer. A cubic function divided by a linear function is a quadratic function. No, not if there's a remainder. For example, this would give you x squared, remainder of -1. So really, your quotient is x squared minus 1 over x, and that is not a polynomial. Set of polynomial functions is closed under division. No, not necessarily. Same reason if you have a remainder. This would give you x plus 1 over x, and that disqualifies it.